Alright guys, so I'm going to do a video on making an 8-channel Mosfet interface board for Arduino. These things, if you're looking for an alternative to these relay boards, these things kind of suck. They're capable of 10 amps. They're mechanical relay, so eventually the relay is going to fail. They're not going to last forever, so you can't replace the relay. They're soldered in, so regardless if you're going to repair it or replace it, you still got to unwire the whole thing to replace one relay. It's stupid. So an alternative is to run automotive relays, and then you can get something that's a little more bulletproof. These are 40 amp relays, and then there's other stuff that you could power with this. Now this is a sync type MOSFET, so you're not going to run power through these. You're going to run 12 volt ground, which is fine. If there's a failure, if the ground bleeds back to the board, it's not going to destroy the board. You could relay the power from one of these, but then you risk if the MOSFET fails and then feeds back to the board, then you're going to feed back 12 volts to the board and basically fry your board. So it's better to use a sync MOSFET for this. And besides this, you're probably going to have these in a box, so you're not going to be running live power to the relay very far. It'll all be contained in the box, and then of course you can circuit protect that. But this is an 8-channel board versus this 8-channel board. So yeah, like a lot of times I've had to basically wire into one of these so I can power the coil on one of them. It's kind of dumb to power a relay to run another relay that actually can get the work done. So this is a better alternative. It's cheaper, and these things are like $3, and I think I paid like $3 or $4 for 10 of these MOSFETs. These are 30 amp MOSFETs with 60 volts capability. However, I would not use this for a continuous load. It's best just use a relay to transfer the big power. Alright, so I'll show you how this works. So basically I just got the blink example from the Arduino IDE, and I'm output pin 13. I'm going into the gate of the MOSFET. So these are in line with the pins of the MOSFET. So that's your gate. This is your drain, and then this is your source. So let's see if I can get a. So if you can see this. This first one here is the gate. Your center one is the drain, and then the outer one is the source. Okay, now how I made this. Fairly cheap. You can buy these. You buy like 5 of these for like $5, $10, something like that. It's just Arduino Nano screw shield. Basically what that is. The problem is the foil making the connections from the pins to the screw terminals just isn't enough to carry the amps. So to remedy, the remedy is to replace that. Alright, so we got our basic board, we got our screw terminals, and then the header pin. Alright, now we're not going to use these. What we're going to do is get the header pins with the longer pins, right? And then what we'll do is, once we get this all assembled, we basically bend them pins over to the terminals on the screw terminal blocks to complete the path. And now we got a good solid connection that can carry the amperage. Alright, so this is a 40 pin. I believe they're for a Raspberry Pi, but I don't know. You can find them on eBay, Amazon, Adafruit, number of sources. And then since these kits already come with a header pin, to trim these down, you just use the header pin you're not going to use. And then you can just trim it. If you're worried about the end there, you can use some sandpaper. Okay. So that would fit in here like so. If I can get it started. There we go. So it goes together like that. Alright, now before you assemble this, you may want to paint this, because now it's got all the pinout for the Arduino Nano. We're not going to be using this for an Arduino Nano. So what I do is I just paint them with flat black paint. I actually lost the board that I was going to build. Here it is. Alright, so this is after paint. Okay. Okay. I had to get my soldering iron warmed up. Okay, so next is we're gonna install the screw terminals on each side. And what I'm going to do is the fourth pin in from each end and the center we're not going to use. So I'm going to use them as anchors to anchor this together. Alright, and then I'm going to do the same thing with the header pins. I should probably put my glasses on. There we go. There's one. Alright, same thing. Alright. Now, alright, so now what I'm going to do is I'm going to trim those pins. Actually, that might be hard. Actually, that's not how I've done it before, actually. Alright, so what you're going to do is bend these pins over And then what I do is I trim the tip off just so it's just shy of the pin of the screw terminal blocks. So I don't know if you can see that. So we'll do this one here. Now I'll trim that fourth pin. And I'll just keep working my way down. Alright, this is the center one, so I'm going to trim that one. That's the fourth from the other end. Trim that one. This one's a little short. That's alright, I'll get the solder to stretch. Alright, so that's one side. So you could go do the other side, but just to keep things short here. So basically I'm just gonna that was that short one. Drinking coffee. Should probably wait till after you do this. Hard time with that one. Alright, so that's one side. Alright, so now one thing I do with my MOSFETs is I'll cut the pins down because they don't need to be, otherwise they're long and it stands up taller, you know, it keeps it more compact. You trim them, and then I put heat shrink on the on them to keep them separated. You can do them all, or you can do every other one, but the heat sink, or whatever you want to call this thing with a hole, that's actually part of the drain. So if they're all touching, all your drains will be touching. So you'll get unwanted things happening. So you'll want to put some heat shrink tube around them to keep them isolated. But other than that, that's pretty much it. It's just an Arduino Nano shield with just the header pins replaced with the longer ones, and then you just solder them direct to the screw terminal. And then you got a tiny 8-channel interface board. Alright, I hope this helps. Thanks for watching.